Good morning. Myself is Bhattacharyya. I am presenting the data link layer noisy channel protocol. Now, we all know that how the data is actually transferred from one machine to the another machine via the WSI layer. Actually, the WSI layer is divided into 7 categories. The first one, physical, data link, network, transport, session, presentation, and application layer. Here, we are dealing with the data link layer. Now, when the data is passed through the data link layer, it is possible that some of the interference may occur during transmission, and the particular frame which is transmitted from one location to another may be corrupted, may be destroyed, may be lost, may be delayed. Several situations can arise. So, to deal with that in noisy channel environment, we need some protocols. The protocols are: number one, stop and wait ARQ, stands for automatic repeat request. The second one, go back in automatic repeat request. And the third one is the selective automatic repeat request. We'll go through this section one by one. The first one, the stop and wait automatic repeat request. The diagrams. Now suppose what is there? It is, suppose we want to send 0, 1, 0, 1, 0. These are the number of frames. So in the sender side, there is a control variable which stands for SN. That is the next frame which we want to send. And then in the receiver side, there is another control variable that stands for RN, which is pointed there to which frame is actually received there. Now the sender side, actually what is the data is transferred from the network layer, is passed to the data link layer, and via the physical layer, that particular frame will flow to the receiver side, and receiver will accept that particular frame and deliver to the network layer. Similarly, the receiver mark and send an acknowledgement frame with a particular frame, and transfer this acknowledgement number to the sender side. What are the events is occur? The events are occur request from the network layer, and there is an algorithm side on the sender side. That algorithm will flow continuously until all the data is transferred to the receiver side. Similarly, there is another algorithm which goes to the receiver side that will follow. Okay. The events occur notification from the physical layer when the particular frame is arrived to the data link layer, and similarly there is an event also in the receiver side. Now, there is an example of the stop and wait ARQ. There is one sender and the receiver. Suppose these number of frames we want to send. Okay, so sender, there is a control variable SN is marked a particular frame, that is 0, we want to send. So it sends a frame 0. These are always in inclined manner because due to the propagation delay, and these particular duration is the transmit time, that is the first bit time and the last bit of transmission, and the entire this blue mark is as a propagation. That's always these things are in inclined manner. So the frame 0 is arrived to the receiver side with a safe and sound. Okay. Now receiver, when particular receiver receives the frame, it moves this control variable to the particular another number 1, that is it sends an acknowledgement 1 to the sender side. Here in the stop and wait ARQ, sender sends a frame 0 and receiver sends an acknowledgement 1. The process continues. The next one, the sender will send the frame 1, receiver will send acknowledgement 0 and continues. Okay. Now, when the acknowledgement 1 is arrived to the sender side, within the time period, that means when the sender sends a particular frame, okay, it starts a timer, and the timer will wait up to a particular time. Okay, within the time period that the acknowledgement arrived to the sender side, then only it is marked as a successful transmission. In this case, in the first scenario, acknowledgement 1 arrived to the sender side within the timeout phase. So the control variable of sender side, which was actually marked with the SN in the initial position 0, now can move to the next frame to send. Now it sends the frame 0 which is lost during transmission. This is possible during transmission, frame could be lost. Okay. Now when the particular frame is lost during transmission, receiver, see that receiver is expecting that frame 1. Once the frame 1 will received within the time period in the receiver side, it will send an acknowledgement, but the sender starts a timer. After the timeout phase, it sees that there is no acknowledgement arrived from the receiver side. So it after the timeout phase, that is the timeout phase, sender control variable still point to the 1 because there is no acknowledgement from the receiver side. So the sender will again resend that particular frame to the receiver side. Okay. Once that particular frame is received on the receiver side, it sends an acknowledgement 0 to the sender side. Again, that particular frame, for the particular frame, the receiver expect that frame within the particular duration, that is acknowledgement within the particular duration. So when that acknowledgement arrives to the sender side, it moves its control variable from 1 to 0 because acknowledgement arrived within the particular time. So it stops its timer on that particular time because it is already arrived. Now sender again starts its timer because there is another particular frame 0. So control variable, it sends frame 0. So it receives on the frame receiver side, it sends an acknowledgement 1, but this acknowledgement is lost during transmission. Now what will happen? There is no acknowledgement in the sender side. So the sender assumes that either the frame or the acknowledgement could be lost. It sends in again the frame 0. Okay, after the timeout phase, it waits for the duration of the timeout. After the timeout phase, it sends and frame resends the frame 0. But that particular frame, the frame 0, is already arrived to the receiver side. So what the receiver will do? The receiver simply discard that particular frame 0, because the frame 0 is already in the receiver side. It sends an acknowledgement. On successful arrival of the particular acknowledgement in the sender side within the time period, then the transmission is successful. So the control variable of Sn at the sender side will move to the next one. The process continues in the time domain. So this is the example of the stop and wait ARQ. Now we'll move to the go back in ARQ. Now what we see that in the selective, what we see is that in the stop and wait ARQ, we can send only a single frame at a time. Now if it is possible that if we can send the multiple frames from the sender side to the receiver side, then acknowledgement will arrive. That will be far better compared to the stop and wait ARQ. So there is a mark frame in the sender side, that is SF and SM. The first, which is view, is which we want to send, and the next one is what we want to send. And the receiver side, the next frame to receive. The process continues with the frame, and there is an acknowledgement number. See that in the first case, stop and wait ARQ, we can send a single frame. But here in the go back end, we can send multiple frames, and the receiver will reply with an acknowledgement. There is another timeout phase in the sender side. There is an event also occurred, request from the network layer, and another event will occur from the physical layer, and the algorithm in the sender side and the receiver side. Now see the example of the go back end ARQ. There is a sender again and the receiver. So this is the total frame. We want the frame, the number of frames we want to send. So there is a two pointer, SF and SM. I hope you remember that there is an only single pointer in the stop and wait. Here is a two pointer. First starting point and ending point in the sender side, but there is only one control variable, that is Rn in the receiver side. This is the initial position. Initial position, it is marked. So if we want to send that frame 0, first one frame 0, it sends. It is possible that we can send a single frame, we can send multiple frames here in the example. So we can send the particular frame 0, which is arrived to the receiver side safe and sound. So receiver control variable, which is currently at 1, sends an acknowledgement 1, which will support the frame 0. Now frame 0 is arrived within the timeout phase. This is the entire timeout phase because we can send multiple frames. So the timeout phase will cover the entire thing. So the arrival of the acknowledgement 1, it moves to the 1. See that this particular frame is actually moved to this location now. So SF now pointing this SN1. So it can send the frame 1. See that SN now move to the next position. So it can send the frame 2 also. Not wait for the single frame. Restricted to the single frame. It can wait the multiple frames. Frame 1 and frame 2. Okay. The receiver control variable move to the number 2. It can send the acknowledgement 2, which will support both the frames, frame 1 and frame 2. But this is lost during transmission. Now what will happen? What happens is that there is a frame, a control frame. We can send the number of frames within that particular window. Now it can send another frame, even if the acknowledgement is lost. So it can send the frame 3. See that SN is moving to this window. Okay, it can send frame 3 and the receiver sends an acknowledgement 3. Acknowledgement 3 will cover the frame 1 and frame 2 is arrived to the sender side, receiver side, safe and sound. So even if there is acknowledgement is lost during the transmission, acknowledgement 2, it will not affect the continuous flow of the data because acknowledgement 3 arrived within the sender side within the time period and that will cover the frame 1 and frame 2. Now it sends the frame 3. The receiver sender sends in frame 3, which is marked by the acknowledgement 4. So the control variable is moved to the next location and the total window moves to the one location because acknowledgement 4 will cover the entire frame 0, 1, 2, 3. So 4 frames is already at the receiver side, so it will cover that number of frames and it is introduction in the time domain, continuous process. So this is the go back in ARQ. Next, we'll learn that is the selective repeat request ARQ. What is that selective repeat request ARQ? Here we have another advantage, acknowledgement number or even the negative acknowledgement. That means if a particular frame is lost during the transmission, it will mark that their particular frame is lost. It sends a negative acknowledgement regarding that particular frame because it is necessary to send that particular frame. It is not necessary to send the entire frame from the beginning. Okay. Now there is again another control variable from the sender side, SF and SM. Okay. In the receiver side, there will be the two control variables. So we'll see in the example. The sender and the receiver, the process events will occur. You can send multiple frames. The receiver will send the acknowledgements also, multiple acknowledgement. There is an event occur from the network layer. In event over the physical layer, there is an algorithm will start and there is a timeout phase. See the example. The selective repeat request example. Now, again, there is a sender and there is a receiver. So, initial position, there is a two control variable. In the initial position, there is a two control variable. So, what will happen that initial 0 and this is the window. We can say 0, 1, 2, 3 and 4. The control variable of that is receiver side Rn, it will move along that. In the previous cases, I'm going back. In the previous cases, see that the control variable go back in, there is a window is of only 1 in the receiver. In the stop and wait, window is of only 1. But in this case, the selective repeat recur window size is increased. Okay. Now what is the advantage of that? Now after the initial position, there is a timeout phase again. At the center side, to send the control variable is currently pointing to the 0. Okay. So it sends a particular frame 0 to the center side. On successful receipt of that particular frame, frame 0 is delivered to the receiver side. The control variable Rn moves to the next. See that this one is moved to the next. Okay, the window move to the next type of sliding. Okay, so it sends an acknowledgement 1. Acknowledgement 1 arrived to the sender side within the timeout phase. So the control variable now move from this location to the next location, 0 to 1. Even the window slides from 0 to 1, 2, 3 and 4. Initially it was pointed 0, 1, 2, 3. Now it points to the 1, 2, 3, 4. Because 0 is already on the receiver side and there is an acknowledgement. Now again, what is the advantage? Advantage is that it sends the frame 1 which is lost during transmission. Okay, frame 1 is lost during transmission. The control variable just up to SA like that. It can move, send another frame even if even there is no acknowledgement from the receiver side. This is advantage. So it sends frame 2. The control variable R points still on the 1 because it is expecting frame 1 from the sender side. So control variable Rn sends from the receiver side there is a negative acknowledgement because frame 1 is lost during transmission. You need to send only the frame 1, not the entire another frames, frame 2, 3 like that. No, that is not necessary. It sends negative acknowledgement 1, NAK back 1. In between time, it sends the sender, see that number 1, 2, 3 because it sends the number 1 timeout phase of that particular frame, timeout phase from the receiver side for particular frame 2, timeout phase for the frame 3. Okay. Sends the frame 2 and frame 3 which is marked. Those frames are arrived to the sender side which is marked with a color here. 2 and 3 arrived on the receiver side. Okay, there is no problem. So a negative acknowledgement upon receipt of the negative acknowledgement, now sender knows that there is a lost frame case. So we need to resend which one? Frame 1. Okay. In the go back end, we need to go back to the previous position, control variable, and then can send the frame. But it can see that which frame is lost. Okay. So it sends that particular frame. And the receiver sends acknowledgement 4, which will cover 1, 2, 3 and 4, all the frames. 0, 1, 2, 3 and 4. Okay. Acknowledgement 4, all the frames 1, 2, 3, 4 covered by acknowledgement 4. So there is not necessary to send again the separate acknowledgement from the receiver side. Now the cursor, that is window, can move to the location from 3, 0, 1, 0, 1, 2, 3 is already received. So it can move to the next location, that is 4, 5, 6 and 7. This number of frames we can send subsequently to the receiver side. Similarly, in the receiver side, it can move to the window can move to the next location because frame 1, 2, 3, frame 1, 2, 3 is already delivered and this is marked by the acknowledgement 4. So this is selective repeat request ARQ. Okay. These are the overall discussion of how data link layer control protocol actually acts with the noisy channel. Thank you.